I'm Robert Otręba. I'm CEO and one of the co-founder of Grinn company. And today I would like to tell a little bit more about how Edge AI can help us to solve some problems, especially with connectivity. At Grinn, we are experts in electronics design, IoT, and edge computing. So today I will try to showcase you a few potential problems that you can find during making your applications and how, what are the tools and how we can help to solve them. So probably everyone knows this slide. There is many flavors of this slide, but the main message from me here is that there is a rapidly growing amount of connected devices on the market, and for sure trend will follow. Of course, we can discuss if these are accurate numbers with how many billions of devices will be on the market, but for sure this is a growing amount, and everyone see what is the trend. And it provides also a lot of problems because, at least from our perspective, most of the designs that we are doing for our customers, these are connected devices with different type of cellular or wired connections. And those devices are providing data to the cloud. Right now was the trend that everyone would like to collect as many data as possible from as many sensor sources of data. And it creates a problem because very often the connection is, there is no connection in the fields of our applications. There is still, the amount of devices is increasing, and this creates a problem that at the end we would like to have a meaningful meaning of those data, not only raw data in our system. So we can imagine also that there is a lot of potential applications and a lot of needs for implementing devices that should bring us data from spaces when there is completely no connectivity. So only for probably satellite communication or low bandwidth communication like LoRa could provide us, but advanced sensors or advanced systems with cameras can't use such connectivity to provide us data. And there are also energy constraints because very often, especially in the middle of nowhere, like monitoring the gas pipes or tracking kettles or different type of such applications, there is no enough energy. So we have to think about building our solutions in such way that we could either use the batteries to power them or some energy sources like PV panels, or we can use the energy but with the restrictions. So the main problem is that we need more data from more type of sensors, more type of devices, and very often there is no stable power source. So we have to find a solution how to fix this problem. And of course, this problem could appear in different type of verticals, like from oil and gas monitoring to cold chain monitoring, smart agriculture, supply chain tracking. We would like to know how bridges or rails, in which conditions they are. And also there is a lot of private medical devices that needs to analyze data and send them to the cloud. So what is the answer, how to fix those problems? Of course, this is not the magic recipe that will work for all kind of applications, but for sure, Edge AI can help us to mitigate those problems. So for sure, reducing the bandwidth of the communication, so using the low bandwidth communications like LTE-M, narrowband NTN or LoRaWAN could help us to reach the data from this from the fields that there is no regular cellular communication. Of course, calculating on the edge, so using edge AI algorithms to solve the problem on the edge could also help us to limit the amount of data that we have to provide to the servers. So instead of calculating everything on the cloud, like right now it's it's in most cases it happens like this, we could solve the problem directly on the device level. Another benefit is that if we need real-time applications and we have to take the decision on the edge, Edge AI can also help here because communication latency, cloud calculation latency could also add some additional latency into the whole chain of solving the problem. And of course, because of that, implementing the more smarter devices in the field, we could ensure that they could work in different places when there is completely, let's say, there is very weak and unstable connectivity. So how as a Grinn we can help you to, well, let's say, to make it, it's not only the, let's say, how we can help, but there is the whole ecosystem of partners that we are working with and that we have to keep in mind. So we as a Grinn, we develop a few system on modules that are dedicated for edge computing, for edge AI. So here I'm presenting two modules, one which is based on a MediaTek Genio processor, multi-core processor, and AstraSom, which is based on Synaptics SL1680 processor, which is a 4-core Cortex A73 with built-in 8 TOPS NPU and also GPU inside. So we are providing, you can imagine that these are Lego bricks that around this we can build our devices. And instead of sending everything to the cloud, we could calculate and train our models directly into those devices and later on send only necessary information to the cloud. So we are not only providing the system on modules, but also there is a variety of boards like reference designs, dev kits to help to enable our customers to make their products happen. Maybe I would describe how we could approach to, let's say, to create the new solutions with integrated AI, with Edge AI. So of course, at the beginning, there is always some problem that needs to be solved because we are not building solutions just to have the new products in our portfolio. Typically, they have to solve some real life issue. So once we know what is the problem and what is the end application, it could be, for example, tracking people behavior on the streets or counting animals or detecting some objects in the public spaces, on the roads, on the manufacturing plants. In most cases, such applications were solved in such way that there were connected cameras. Cameras were streaming encoded data into the cloud, and all AI analytics and problem solving was done on the servers. Of course, it means that the cameras need to be equipped with high bandwidth connectivity. We have to pay a lot for data. And the problem that was described before, very often there is no stable connection for such type of applications. So right now, because of the fast development of electronics and also that manufacturers of the chips are also implementing the neural processing units inside of their chips, we can solve those majority of those problems that were solved on the cloud side, on the device level. So then, of course, once we know what is the problem, for example, recognizing people on the street, we don't need the, let's say, high computation unit, let's say, the servers to make it. It can be easily done with the system on modules that I was presenting. So once we know what is the problem, we can select the right hardware. And in this case, if this is the camera connected sensor, so the device needs to work as a camera, but doesn't need to provide the whole stream of data, but only the meaningful decisions or information to the cloud. The answer could be the SL1680 processor from Synaptics. But of course, this is highly integrated part, very complicated design. It will take time. So what is our answer for that? We created the very small form factor module, which is 43 by 37 millimeters. And this could be an answer how to accelerate the project, because instead of designing everything from scratch, we can use the advantage of ready-made hardware and start implementing this in our project. Of course, this comes with a reference design. So this is a development kit, but it's a little bit more than development kit, because we are even providing for this the step files, so it could work as a single board camera with integrated image sensors. Power over Ethernet, HDMI for supporting debugging, USB for additional connectivity if it's needed. And also we have place for connecting either cameras through the flat tape cable, or on the other side there are MIPI connectors. So this was the hardware road. We have to, of course, to solve the problem, we have to find the tools to solve our problem. Of course, in parallel, we have to think about how to work on the proper software layer to solve the problem. So first of all, in like most AI-based projects, we have to develop or download or find the algorithms, models that could solve the solution for us. For detecting people, it could be we can either use the Tao models from NVIDIA, it could be YOLO algorithm optimized for embedded. So once we know what are the let's say what kind of models we would like to use, and we know how to train it with our database, then of course we have to test those models, simulate them, and at the later stage also inject them into our hardware to check how it works. And I will come back to this, especially to this step, because it's also important to understand that maybe not exactly the same models that are used on the servers we could implement on the edge devices, because of course it's uncomparable computing power. But computing power in such devices are huge enough to, let's say, solve the example that I'm showing here. So of course, once the AI algorithms are done, there is a application layer that needs to be implemented on the device, and also communication with proper security. And for example, our board is also prepared to provide such functionality, because we know that most of the devices need to be connected. We have to provide the data at the end to the end users. So answer for that could be the say M.2 connector, where we can slide different type of connectivity modules, and then using some of the vendor of the connectivity module, like in this case Murata. Or then we can connect it with Onomondo connectivity to provide data to the cloud. Or if there is no reach of the cellular connection, we can use the Skylo as a NTN satellite provider. But this module, for example, is only can serve LTE-M, narrowband, and narrowband NTN. So it means that we have only limited amount of data that we can send to the cloud. But because of that, because we will solve the problem on the device level, we will be able only to send the information, what happens, and the real problem solver. Yeah, coming back to let's say to those models, because we can of course train our models on the PCs, on the cloud side, but at the end, if you would like to make the edge AI application, we have to implement them on the hardware layer. So typically, the road to have a solution is exactly the same like with, let's say, server approach. So we have to have a data set, model architecture. Once we know it, we have to train the model. And there is additional step that is very important in edge AI. So model quantization and pruning. So it means that we have to optimize the model that works well on the bigger machines, that they will be able to run on the edge devices. So quantization means that we have to optimize a little bit or cut the the accuracy, and the pruning we have to also the more optimize it also from the cut a little bit the accuracy of those models, but they in such way that they will be good enough to run on the embedded devices. And typically changing, I don't know, the integer, let's say the floating points into the integers, or I don't know, limiting the amount of cutting some of the wages in the neural networks could give us similarly good results, and so it will not affect the end application, but the models will be such optimized that they could work on the edge. And then, of course, at the end, we have to deploy those models on the hardware platforms. And this is very nice that both partners that we are working with, they are providing dedicated tools to, let's say, for model optimizations that they could be integrated inside of the hardware. Yeah. So at the end, once we know what kind of problem we would like to solve, we know what kind of hardware we would like to use, we know what is the path to solve the software solution, we know what will be the type of communication, how to make the secure firmware upgrade, and so on. We can think about how to finalize the device. And here, as a Grinn, we can also help giving our advices or making the complete design. Of course, I'm not recommending to use this for final products. This is just the inspiration. But what is nice that we are providing the schematics, PCB layout, bill of materials to such board to make the design faster and more efficient for our end customers. Of course, at the end, some of the customers don't need Ethernet. Some of customers will not need the, I don't know, M.2 connector because they would like to have implemented module on their board. But this is just the tool to help to speed up development process and to be more efficient. Yeah, so going from such board, prototype board, we can then transfer our projects into the real PCB design. Of course, we have to think about EMC tests, FCC tests, all kinds of certification that are needed. We have a lot of expertise to help our customers in this field, but of course, it could be done by third parties. And of course, at the end, it's preparation for mass production. So in this case, building production testers, what we are also doing as a Grinn, and find a good EMS partner to produce it. So of course, as a Grinn, we are not alone on this market, and we are providing just a small small part of the larger ecosystem. And this is how most of the projects are looking, that we are trying to find best solutions from existing ecosystem to speed up the development and to find expertise from other companies, and we are combining this together. So in case of processor suppliers, we are working with Synaptics, MediaTek, Renesas, Nordic, NXP, but it could be, I don't know, ST or any other vendor. In case of communication modules, there are also many vendors for that. For connectivity providers, it could be one of our partner, Onomondo, but it could be also other connectivity provider. If the NPU inside of our solutions are not good enough, or in your solutions are not good enough, there are also companies on the market that are providing hardware accelerator for additional TOPS. If you need additional TOPS in your edge AI applications, then there are companies like Hilo and Dipex that could accelerate even more your calculations. And if you need the security platforms to make your device secure with secure updates, then there are also partners and companies that could help in this field. We are working with Tristle, for example, in this case. Of course, these are not all our partners, not all companies that we are working with, but this was just to showcase that to really be efficient with the time implementing new ideas into the market, of course, we can do everything ourselves, but we can also use the Lego bricks from different suppliers to make the smart devices faster. And there is, of course, plenty of applications. I can describe a few of those that we've been working. Last year, we've been working on the device that was a collar for live storm monitoring, but not only for monitoring where the animals are, but also to detect if they are still alive or they died, just to, let's say, collect the body from the nature. And of course, sending the, I don't know, once the message about the location every 10 minutes or every hour would mean that we would need to have large battery in the system, which would be problematic. Or we can think about implementing the AI algorithms to make the detection and send only the information, for example, once a day, what was the track and if animal still alive or not. So to solve that problem, we've been implementing AI on the microcontroller level. So we've been not using our modules, but it was implemented on the microcontroller level to be even more efficient with the battery. Another application, it could be detecting the fire in the forests or different type of let's say objects. We don't need to constantly send the video stream to make the detection and to really solve this problem. We could have implemented camera that will analyze the image and then send the information to the cloud only when something will happen. And maybe smaller video if it would be needed, or just a snapshot of the picture to showcase that this problem really exists. This also perfect example how Edge AI can help us to solve such problem. It could be smart traffic detections, I don't know, such applications like in monitoring of the application. This is also application that we done on the board that I shown before. That's just to showcase, let's say, how we can use Edge AI and how optimal it could be. So we made let's say the application on the gates for plate recognition. So we are not streaming any data, let's say, any video to the cloud. Everything is solved on the hardware level. This hardware platform was able to scan, let's say, to operate with 2 cameras with 30 frames per second using integrated NPU. So only information that we've been sending to the cloud was the recognized plates with the timestamp, and the same information goes through the cable to the gate opener. So because of that, we could, without putting any cards, we could just open the gates. But everything was solved on the edge level. So summarizing the biggest benefit of, let's say, using Edge AI with communication devices is that we could send only information that are really necessary to be sent. We could have faster response and we could be really real time. We can consume less power because in many applications the communication it's drawing most of the power from the devices. And we could implement some of let's say the devices, sensors, advanced camera systems in the places when there is almost no connectivity, just providing the problem that was solved. So, of course, as a Grinn, we can help across the whole road from idea up to the ready-made product. We have a growing portfolio of system-on modules that are highly dedicated for Edge AI, so we can help how to make the PCB, how to implement the models, how to support the SDK provided by the chip vendors. We can also help with end application, but these are just tools that for engineers that other engineers can also use as a Lego brick. We have also expertise in Edge AI and optimizing the models. So at the beginning, when we've been starting our journey with this, it was a little bit foggy for me that I didn't know too much information. I was afraid that it's a completely different topic. We don't know how to make the projects with such technologies. It turned out that it's not such problematic, and we build such expertise inside of our company, and we can share it also with our customers. And at the end, we can also help to build the dedicated hardware, turn it into the production, and help our customers to make it happen. But yeah, this is only the way how we can help, but probably all of our customers have their own ideas how to do this. Thank you very much. If there are any questions, I hope that I will be able to answer. Okay. There is.
What size quantizations are you normally using for them to run on the embedded systems?
This is good question, but if we can connect each other, because then I will connect you with our experts exactly in this field. Because yeah. Yep.
Hi. When you mentioned the Edge Eye and what it could do, would you be able to detect if people were smoking in a room?
Yes.
Or vaping?
Yes, yes.
And can you distinguish between the two?
Sorry?
And can you distinguish between the two? As if somebody was vaping or somebody was smoking?
I'm more than sure that yes. I'm more than sure that yes, because, for example, in our booth, we are presenting one of the demo with Edge AI implementation, where we are able to detect the depth of the image just using standard RGB camera, like a webcam, without any additional lidars, any additional, I don't know, proximity sensors. Just through the trained model, we've been able to solve, let's say, such problem that from normal camera we could reach the depth. So distinguish between the vaped smoke and the real smoke. I'm more than sure that it should be possible with the properly trained models. Of course, the better accuracy we'll be able to reach if you will have, let's say, data sets from different type of, let's say, environment, lighting conditions, and lot of, if we will have a good data set and we will train our model in the efficient way, I'm more than sure that it should be possible to solve such problem.
Okay, thank you.
Mm-hmm.